Hi friends, I'm Amit Kumar and welcome to Technical Education Classes. In this class today we will study about hard disk drive components. This is the second part of previous lecture. The first part of this session is plotters. A hard disk drive stores information on one or more flat circular disks called plotters as shown in this figure. The platters are mounted on a spindle with space in between and a motor on the bottom end of the spindle as shown in the bottom figure. The given picture shows the disk plotter of a hard disk drive. The plotter size, that is diameter, is called the form factor of hard disk. The plotter size are 5.12 inch and 3.74 inch. These plotters were made from aluminium alloy because of their strength and lightweight. The newer hard disk or HDD uses glass and glass ceramic plotter. These plotters are coated with magnetizable media. This media coating stores information magnetically. Two types of recording media used in hard disk drive. First one is iron oxide media and second one is thin film media. Iron oxide media. Initially, all the hard disk drive plotter surface coated with an iron oxide compound. Its recording density is less and it was very soft and crash of the drive head dead on the plotter used to make permanent defect on the media coating. Our next media is thin film media. The thin film media coating is very thin compared to the iron oxide coating. The thickness of the coating allows the hard disk drive head to be positioned very close to the disk surface, which is very high density coating. The thin film media provides a very hard and perfectly formed media coating which can withstand head crash without destroying the coating. Once media spread evenly across the plotter surface, the surface is cured and polished. The polished surface finally coated with some lubricating material which protect the surface from minor crashes. The media is created on the plotter surface using two different processes. They are plating process and sputtering process. What is plating process? In this process, the plotter substrate is immersed in different chemicals to coat the plotter surface with a very uniform 2 to 3 micro-inch thick cobalt alloy coating. Next is sputtering process. This provide better thin film coating compared to the plating process. This process providing thinnest, hardest and finest media surface. In this process, the plotter substrate is first coated with a layer of nickel phosphorus and then on this surface cobalt alloy material is depositing using a sputtering process. The advantage of the sputtering process is making it one or the most common disk media creation process. The only problem with this process is the high cost. Next part of this session is read-write head of our hard disk. You can see in this picture this is head arm. At the tip of this head arm our read-write head is mounted as you can closely see in this picture. This is very close picture of our read-write head. In this picture it is used to write any information on the disk surface and to read the written data back without any data loss. A hard disk drive contains one read-write head for each side of its plotter. For example, if a drive contains 3 plotters, then total 6 read-write head will be used to read the two sides or each plotter. This picture shows that how our read-write head is situated over the plotter. All head used in disk-driven system is connected together and moved in and out on the disk surface as a single unit. One can't move different head in different order. The HDD uses different types of head for read-write purpose. Some of them are as follows. First one is ferrite head. This was the original hard disk head made by the IBM for Winchester disk drivers. This head is made of iron oxide core wrapped with electromagnetic coils. This type of head cannot be used to store higher density data. This type of head is obsolete today. This picture shows very close view of read-write head arm with its mechanical parts. You can see so many mechanical parts are arranged so that it is work very uh, close to plotter surface and very flexible in its movement. Second is metal in-gap head. This type of head made of a metal alloy is placed in the recording gap on the trailing edge of the head. Metal in-gap head could write to high-density thin film media used in high-capacity drives. Third is thin film head. It is very small and lightweight heads which can be used to close as 2 micro inch or less to the disk surface, that is plotter. These heads are produced using a photolithography process. This head made by an iron nickel alloy core is used, which is 2 to 4 times magnetically more powerful. The head gap of this head is very narrow and is completely enclosed with hard aluminum material which protects the head from any crash with the disk surface. Our next type head is magnetoresistive head. This head is designed by the IBM and it is superior to all other current head design. This head used in 1 GB or more capacity drive. This head works on a different principle that when a magnetic field is present near the conductor, the resistance of conductor changes. The head design required two separate heads, one for writing and one for reading. This picture shows mechanical arrangement and optical positioning of our read-write head. Our final type of head is Ghent magnetoresistive head. Ghent magnetoresistive head GMR heads are smaller than previous head. This head added one or more layer nickel ferrite in conventional MR, that is magnetoresistive head. Today this head is used by hard disk. At next class we will study next part of this lecture. Thank you.